Howdy Calc BC. Just a quick video, given that we've been talking about a lot of these applications of integration and we have an assessment for that on Tuesday, I thought maybe I should put together a quick video just kind of to remind everybody like what are the applications that we've been focused on, because it has been a while since we took our last assessment. So I just thought I would run through those real quickly, and then if you have questions on any of these, obviously we have the videos previously that review all of them, or in class on class day we probably have some time if you want to run through an application or two. So just wanted to do that real quickly. So let's take a quick peek at the applications that we've seen thus far, and then we'll take a look at what we can expect to see on the assessment then. So yeah, so the idea is, well, let's get a, there we go. We're talking about applications now of integration, and there have been many that we've talked about. Most recently we did centroids, right, / center of mass. And so, I don't know, we need to review that one too much. We did work done by variable force. So that was that idea, that work increment, right? Figuring out how we're going to, whether that's a force increment times the distance or a force times the distance increment. That's really what it comes down to. Previous to that, we did arc length. Oops. Arc length and surface area. Now on those ones there, I know typically I don't give you equations and stuff like that, but because that's kind of pushing the limits in terms of what you might see on an exam, like the AP exam, I'll probably give you the equations on those ones. Those aren't ones typically that they expect you to memorize. Prior to that though, the volumes, either disk, right, the disk / washer method. There's the volumes with the shell method, and then there's the volumes parallel cross sections. Those are all, oops, there we go. Those are all ones that College Board, they definitely would expect you to be able to do that on your own. No formulas provided. So do you have to memorize those formulas? Yeah, you probably do really need to memorize those formulas. Sorry, that's just kind of how it goes with those ones. So thinking back then, with the washer method, hopefully, you have that sense of how we find the volume of that one washer, and then versus the shell method, which finding the volume of that one shell. And I think it will really help if you draw the picture and shade the representative rectangle. That's like the one thing that I feel like if you get that down, then I feel like you're going to be in really good shape. Get that drawn, and then because then the radii are sort of they're sort of just obvious at that point. You can see them graphically in your work. So anyway, that's just my tip on that one, is to make sure that you're using the picture. So sorry, digressed on that one there, but I just want to reiterate that that's a big deal. And then we had solving differential equations. Okay, and we had the separable ones, and then we had the solving. There's an L in there. Solving diffie-q for the homogeneous ones. And so I would expect that you would be able to do that. So that's definitely going to be something that I would anticipate you seeing on the exam. So be ready for that. So yeah, I mean, I think when you look back across our body of work, then that's representative of all the work that we've looked at in terms of just applying the integration technique. Well, I guess don't forget area, right? I guess there's always that idea that the integral the definite integral finds area as well. But I think that what we're going to do is see those ones there, uh, not as focused on the area question. I mean, obviously it does that, but I think you want to focus in on these ones right here. So anyway, I hope this helps kind of narrow down your studying a little bit. Centroid, center of mass stuff. Um, I would I would anticipate that it would be a fairly straightforward one. Just remember that to find the center of mass in a two-dimensional system, right? Most of what we want to focus on are the two-dimensional systems. So the sum of the moments that you need, or the moment over the x-axis, the moment over the y-axis, um, and then the mass of the whole system. So focus on that. Work done by the variable force, I mentioned that earlier. Figure out how they do that work increment. Arc length, surface area, don't worry, I'll give you those equations. Volumes, though, you won't get those equations. Solving differential equation, you won't get those equations. So those are the ones you definitely need to know how to do without any of those assistants. Anyway, so that's it. Like I said, I just wanted to throw together a real quick little video for you to kind of help you frame your studying. If you have questions on any of those, I encourage you to go back and check out the videos that exist on those. I did post our class video on centroid and center of mass. That should be in your first semester folder. Somebody said that they can access like all their old Schoology folders, so I'm assuming you can access last semester's stuff, since the semester ended on Friday. And that's about it. So anyway, thanks guys. Hopefully that goes well. And again, if you need help, definitely hit me up with questions before we do the assessment uh, when we get to class on Monday. All right. Thanks guys.